Hi, my name is David Hurd, and this is Lab 2, Lines of Charge. To begin, we must open up with Newton's second law, the momentum principle, which explains how a change in momentum is directly caused by a net force over some given period of time, as well as Coulomb's law, which explains the electric force on an object due to charges present, along with the Coulomb's constant, 9 times 10 to the 9th Newton meters squared per Coulomb squared. In this lab, we're going to see the same thing as lab 1, where the two tapes that will become one positive, one negative. We're attracting each other in the process. And we will see that the different model that we use compared to lab 1 will result in a drastically different answer. The initial conditions are the same, but the purpose this time is to show that different models can give more accurate results when the model itself is more accurate. The experiment is the same. Two tapes of the system, and the surroundings are me, the table, and everything else. And during the experiment, one tape is charged by ripping it off the other, and you hold it close to observe the charges. The same results from the experiment of lab 1 are also present in lab 2, where the length of the piece of tape was 0.2 meters, 0.2 grams, and when they were repelled off of each other, they had a distance of 0.02 meters with a gravitational force and electric force of about 0.002 newtons. All of these are the same because no experiment was conducted for lab 2 since we were using the exact same experiment and results as lab 1, my bad. The majority of this lab comes in the coding, where we used a new code that simulated the line itself, which you can see on the left, where we did almost an integral of all of the different possible places on the tape repelling against the other. This time, we found that the magnitude of the charge from one tape was 3.695 times 10 to the negative 8 coulombs. And our assumptions were the same, except we didn't treat it as a point charge this time, and that is very important. That is the entirety of lab 2, treating it as the full length itself. Now, the same errors are possible, but this time there's a really good chance of the inaccuracy of the distribution of the charges on the tape and the length of the tape and the point charges on the computational model, but for the most part, the error comes from the data, which, since we're comparing it to lab 1, isn't a problem. Now, what if it's the point charge? Well, if you use our data, the point charge yields 1.98 times 10 to the negative 8 coulombs, which is drastically different than 3.695 times 10 to the negative 8 coulombs that we found with the line model. Why is this? Well, they're different models. Since lines of charges are going to naturally produce different results than a point charge, our models, which show each of those separately, are going to be different. And this is kind of important because the more accurate your model is, the more accurate your data and results are going to be, which is really important when you're trying to study small phenomena, because simple things can make drastic differences.